This video is going to cover slope fields and how to make a slope field and actually how it relates to what we were just talking about as far as finding the general solution given a derivative. So I got a derivative equation, x minus 2y. So what a slope field is a graph of that derivative. Well, you can't graph a derivative the way that you can graph an equation, but you can graph the slope field for that derivative. I mean, you could graph this like you would graph an equation, but if I want to kind of get an idea of what y equals, I could graph the slope at any given point. So I get that by plugging in your x value and your y value. So I took all the points on my graph for which x is -1, and I'm going to look at those first. So I got dy dx equals x minus 2y. So therefore, x is -1 and y is 2. So all I did was I just took the equation x minus 2y and I plugged in x is -1 and y is 2. So then I get -1 minus 4, which is -5. All right. So then I go to my graph and I find the point -1, 2, which is right here. Okay. And you graph a slope of -5. And it's just a tiny little line, and it doesn't need to be perfect. Okay. So -5 slope is pretty vertical. It's going to look something like that. Okay. So now I'm going to do the next one. So -1, 1. X is -1. Y is 1. So -3. So you're like, okay, well, I'm going to graph at -1, 1 over here. I'm going to graph a slope of -3. And the key tip that I want you guys to realize here is you're going to graph slopes that are relative to one another. Meaning if I have a slope of -5, that has to be more vertical than my next slope, which is -3. And I mean, that's a little bit, I might actually try to do that one again, maybe a little bit flatter. You know what I mean? So you're trying to graph it a little bit flatter than -5, because, you know, -3 slope is going to be closer to like a 45-degree angle or a 5 slope. And what I might actually do is I might make this one a little steeper just to make it clear that these are not the same. So something like that. So you just got to graph the slopes relative to one another. So I'm going to continue on. -1, 0, x is -1, y is 0. So now this slope is -1. And at -1, 0, it's perfect 45, obviously. All right, so again, it's just a little dash showing you the slope. And then lastly, I got -1, -1. So I got -1 minus 2 times -1, so that's -1 plus 2, which is a +1. Okay, so a +1 slope should look something like that. So now I did that all for where x was -1. I'm going to do the same thing for where x is 0. So I'm going to take 0, 2, 0, 1, 0, 0, and 0, -1. After you do this a few times, you don't necessarily need to write them all out like this, but you kind of just think about it. So the slope at 0, 2, x is 0, y is 2, which would be a slope of -4. 0, 1 would be a slope of -2. 0, 0 is a slope of 0, and then 0, -1 is a slope of +2. So now I got to make sure relative to the 5, -4 is a little less steep and maybe a little more steep than the -3. -2 again has got to be a little flatter than -3, but still less steep than -4. 0 is easy, that's just a flat line, and then 2, something like that. So again, it's just relative to the other points. It doesn't need to be perfect. Just show that you're trying to make these things relative to each other. You know, so like a -5 slope should not look, oops, what did I do? -5 slope should not look like less steep than like a -1, and that's basically the idea. All right, so finishing this off, I got the points where x is 1. So I got 1, 2, 1, 1, 1, 1, 0, and 1, -1. So then I got x minus 2y, so it's 1 minus 2 times 2, which is -3. 1 minus 2 times 1, which is -1. 1 minus 2 times 0, which is 1, and then 1 minus 2 times -1, which actually is +3. So you get -3 here, so a little less steep. -1, perfect 45. Here you're at 1, and then here you're at 3. So again, that's a slope field in a nutshell. And the idea of a slope field is it follows the graph of the original equation, but basically you don't know what c is, so the graph of the original equation, the general solution, the y equals equation, follows the slope field. And that's the idea, is like if I were to graph y within this, it would follow the slopes that I just drew. Meaning like if I put a point, for example, like right here, then as I went left to right with this point, it would follow these slopes. So it would kind of have like a similar thing like you see here. So um, that's the idea. It would follow the points, and that's the whole goal of a slope field. So that's that one. I'd like you to try the next one. So if you pause the video here, but the next answer should look like this. And if you want to get you want to pause it at this point, you can kind of make sure that your answer looks the same, and that's the slope at every point for that graph. So just kind of a little practice. Okay. Hope this helps, and I hope now you can do slope fields.